Hi everyone, it's Math with AUB. Today we are about to solve a question using a row operation, Gaussian elimination. Gaussian elimination leads us to row echelon matrix. After reaching at row echelon matrix, we are in a position to define or find number of what is the rank of the matrix. What the rank of the matrix are, also we can solve the system. Let's see and find out Gaussian elimination method, a rank row echelon in a single shot. Let's see and find out. We have a given system of linear three equations in three unknowns. 3x1 plus 2x2 minus x3 is equal to 4. 2x1 minus 6x2 plus minus 8x3 is equal to 10. 2x1 minus x2 plus 2x3 is equal to 10. They are in order. If they are not in order, settle them in order. If something is missing, right, introduce 0 instead of that. Here there is no deficiency of x1, x2, x3 and the constant on the right hand side. It is in order. Let me write their coefficients. 3, 2 and 2. What about coefficient of x2? 2 minus 6 minus 1, x3 minus 1 minus 8, 2. This matrix is known as coefficient matrix because we have taken the coefficients of x1, x2 and x3. Coefficient matrix. This matrix is known as coefficient matrix. Coefficient matrix. If we write is equal to column on right hand side, then it will called augmented matrix. Now it is our augmented matrix. What we have to do, we need first row, first column 1, and under the first row, first column we need 0. If second row, second column, this entry is 1, we need 0 in under that one leading diagonal 1, and eventually if possible we need 1 here. If there is 1, 0 0, 1 0 and 1, this matrix is known as, some people call it row echelon, some pronounce row echelon, both are correct. Row echelon. We need 1 0 0 here, 1 0 and 1 here. It is known as row echelon. Then we do something else. To manage 1 here, we have one possibility: divide R1 by 3. R1 dividing by 3, it will give us fraction 2 over 3, minus 1 over 3, 4 over 3. There are 3 fractions. If we divide this after interchanging R1 and R3, dividing by 2, it will give me minus 1 over 2 and 5, a single fraction. If I divide this R2 by 2, it will give me 1, minus 3, minus 4 and positive 5. No fraction. Means divide R2 by 2, then interchange with R1. Try to avoid fraction as much as possible as it is avoidable. If it is inevitable, then work with fraction as well. Fraction can easily be avoidable in our case. Dividing by 2, it will become 1, minus 3, minus 4, 5 and interchange with R1, and we are going to manage pivot element first row, first column 1. So we have dividing by 2, after dividing by 2 it will become 1, minus 3, minus 4 and 5. We have divided R2 by 2 and interchange with R1. I have written after dividing R2 by 2, I have written it instead of R1. Now R1 will become, instead of R2, 3, 2, minus 1, 4, R3 same, 2, minus 1, 2 and R10. So we have embarked upon our journey to make this matrix row echelon matrix. There is 1. We need 0 in the beneath column. Under diagonal 1, we need 1. Zeros, overall zeros. It's really very easy. What is position of this one? In R2, we need 0. Position R2, we need 0. We have to vanish positive 3 by the induction of 3. Utilizing R1, or simply make R1 3 times. And subtract from R2. Make R1 3 times, subtract from R2, or what is position, right? I need 0 in R2, I have written R2. I have to vanish positive 3 by the induction of negative 3 times R1, negative 3 times R1, because our pivot element lies in R1. We need here 0 as well, write its position R3. R3, we have to vanish positive 2, positive 2. We need negative 2 times our pivot element. We need 0 here, I have written position, we have to vanish positive 2, I have introduced minus 2 with the help of R1, with the help of R1. Or it is equivalent by saying that make R1 2 times, subtract from R3. Make R 2 times and subtract from R3. You are going to have 0 here, 0 here. Let's see a tiny rough work in that case. A tiny rough work in that case. What is R3? Let me write a rough work 3, 2, minus 1, 4. Multiply R1 3 times. R2 I have written. Multiply R1 with 3, it will become 3, minus 9, minus 12 and 15. We have to subtract, changing the symbols. Now we have 0, it will become 11. It's also 11. Positive 4 minus 15, it's minus 11 as well. I have to write this thing instead of R2. Instead of R2, we have to write 11, 11 and minus 11. What about this? Perform this rough operation as well. R3, write R3. 2 minus 1, 2, 10. R3, 2 minus 1, 2, 10. Multiply R1 with 2, multiply R1 with 2, multiply R1 with 2, it will become 2, minus 6, minus 8, 10. Then we have to subtract. In subtraction, change the symbols, O, positive 5, 10 and 0. I have to write this in tree instead of R3, instead of R3, instead of R3. No change, no transition in R1. Write R1 same, 1, minus 3, minus 4 and 5. Instead of R2, we have to manage 11, positive 11, minus 11. What about R3? 5, 10 and 0. Now second row, second column, entry of second row, second column, we need 1 here, 1 here. If we divide by 11, there is no fraction, we are good to go. Divide R2 by 11, divide R2 by 11, divide R2 by 11, divide R2 by 11, divide R2 by 11. So we have no change in R1, 1, minus 3, minus 4 and 5. Divide R2 by 11, 1, 1, it will become minus 1. Write R3 same, 0, 5, 10 and 0. Now we need 0 here, 0 instead of R3. Where we need 0? In R3, write its position. We have to vanish positive 5 by utilizing negative 5. Our pivot element in R2, with the help of R2. Make R2 5 times, then subtract from R3. We need 0 here. I have written position R3, we need 0. I have written position. We have to vanish positive 5. I have written negative 5. By utilizing R2, our pivot element lies in R2. It is equivalent by saying that make R2 5 times, then subtract from R3. Make R2 5 times, subtract from R3. We need 0 here, write position R3. We have to vanish positive 5, negative 5 with the help of R2 because diagonal element is in R2. Rough work. What is R3? Right? So it is already written. Let me write again 0, 5, 10 and 0. Multiply R2 with 5. It will become 0, 5, 5 and minus 5. Change the symbols, subtract. We have 0, 0, 5. It will become positive 5. Now I have to write this thing instead of R3, instead of R3, instead of R3. I am about to erase this rough work, Now we have we have something like, may I? It's good. We are good to go. Now we have 1, minus 3, minus 4, 5, 1 minus 1, 1 minus 1, and what is here? 0. It's also 0. What about this? Let me do rough work again. R3, 5, 10, 0. Multiply R1 by 5 0 5 5 minus 5. Subtract, we have 0 0 5. We have to change symbol, it will become positive 5. Now this is the entry for our third column, third row. Now we need one here, one here. Our third row, third entry, third row, third column, third row, third column. We need one here. R3 divided by 5. R3 divided by 5. So eventually we have 1 minus 3 minus 4 and 5. O 1 1 minus 1. O 1 1. If you are asked to tell what is the rank of this matrix, this, if you are asked, if you have given such type of matrix and you are asked what is its rank, how many diagonals you have successfully managed, 1 2 3, rank is 3 in that case. Rank is 3. If you have given a matrix, if you have given a matrix, then you are asked to find its rank, manage diagonal one, first row, first column, if possible 1, then beneath column is 0. Second row, second column, if possible 1, then beneath column 0, and eventually the third one, and so on. If there is a bigger matrix, how many ones, pivot elements you have managed? 3. So rank of this matrix is 3. If this type of matrix is given to you and you are asked to find its rank, but we are interested in solving this by Gaussian elimination matrix. Or such type of matrix is known as row echelon. What is the definition of row echelon? Diagonal one beneath column 0. Diagonal one beneath column 0. Diagonal one beneath column 0 if possible. This is row echelon. This is the number of rank I have given you. But let's proceed by using back substitution for finding values by Gaussian elimination method. By back substitution, what is this? This is x1, x2, x3. Successfully write from coefficients the system of matrix again, but in back substitution manner. Back substitution, R3, R2, then R1. We have OX1 plus OX2 plus 1x3 is equal to 1. So successfully our value of x3 is 1. Value of x3 is 1 from R3. What about R2? What about R2? OX1 plus 1x2 plus 1x3 is equal to minus 1. We have 0x1, 1x2, 1x3 is equal to minus 1. What is the value of x3? We have already managed. That's equal to 1. It's vanished. Multiply 0 times. It's 0. x2, value of x3. We have managed. Utilize it 1. It's equal to minus 1. Shift 1 here. So x2 will become minus 1 and minus 1. So x2 in that case is minus 2. X2 in that case is minus 2. From the now moving to R3, R2, now R1. 1x1 minus 3x2 minus 4x3 is equal to 5. 1x1 minus 3x2 minus 4x3 is equal to 5. We have value of x3, that's 1. Value of x2 is minus 2. Utilize here x1. Value of x2 is negative 2 minus 4. Value of x3 is 1 is equal to 5. We have already managed value of x2, that's minus 2, and x1 is 1. Utilizing them, we arrive at the final result of x1. x1 negative times negative, it will become positive 6 minus 4 is equal to 5. Plus 6 minus 4, x1 is x1 plus 2 is equal to 5. Or x1 is equal to 5 minus 2. 5 minus 2 means 3. So our values are x1, x2, x3. Value of x1 is 3. Value of x2 is minus 2 and value of x3 is 1 by using Gaussian elimination method. Gaussian elimination method. If you have given a matrix and you are asked to find its rank, reduce in row echelon form. What is the statement? What is the definition of row echelon? If diagonal element is 1, first row, first column, second row, second column, third row, third column, fourth row, fourth column, and so on. If first row, first column is 1, overall later this column we need 0, under this column we need 0, beneath this column we need 0. If possible second row, second column is 1, beneath this we need 0. This type of matrix is known as row echelon. Now we have reduced the matrix in row echelon form. Row echelon asks, it's our answer. If you are asked what is its rank, how many pivot elements you have managed, 1 2 3, rank is 3. Or you are asked to find values of x1, x2, x3 by utilizing Gaussian elimination. Start from by back substitution. Ox1 plus Ox2 plus 1x3 is equal to 1. That we have to utilize. It will give you x3. What about this? 0x1 plus 1x2 plus 1x3 is equal to minus 1. It will give you the second value. It will give you the second value. And from the third one, you need the final entry x1. x1. That's the method for this one. And it is the backbone of linear algebra. If you are familiar with a row operation, then you are a king in linear algebra. It's my tiny effort to explain to you what do you mean by row operation. What do you mean by row? A single mystery in row operation will make you king of determinant as well as matrices, as well as linear system, whether it is of 3, 4, and 5. It's my tiny effort to you guys to explain to you what do you mean by row operation, Gaussian elimination method, row echelon, or rank. It's all by itself. Next.